Hey all. I know there were some issues with there being no sound for some reason in the last lesson, but so let me just recap what I did real quick so you understand what I was doing, so you understand what the previous video was rather. So let me skip ahead right here. So on this slide, basically what I was pointing out was that when you take a square root of a number, two things. One, square rooting something is the opposite of squaring something. So like when you square something, that's like saying a number multiplied by itself. So let's say 7 times 7 is 49. And then when you square root it, that's the inverse or the opposite. It's like you're going backwards. So the square root of 49 is 7 because what number times itself equals 49? Well, it's 7. And the second thing that I was talking about on this slide was the fact that when you find a square root, it's not just 7. So like the square root of 49 is not just 7. It can be positive or negative 7. And that's important for not just this lesson, but for every other lesson going forward. Remember that quadratic equations can have up to 2 solutions. So they can have 0 solution, 1 solution, 2 solutions. One easy way to find 2 solutions is by using the square root method. Which basically says that, well, if you're finding the square root, then there's going to be positive and negative, because of course remember that a positive times a positive gives you a positive, but also a negative times a negative. So like if you look at that first example on the slide, the square root of 64 is plus or minus 8, because 8 times 8 is 64, but also negative 8 times negative 8 is 64. And then I should also mention as we go to the next slide that one thing that I particularly like is that the square root method is honestly very, very easy. It's on the same level as factoring, maybe even easier actually than factoring, because in general, literally all you're doing is getting the x by itself like you do when you solve any equation. So, isolate the x, do reverse PEMDAS. And then your last step is pretty much always take the square root of both sides, because you usually end up with an x squared on both sides, and to go from x squared to x, you simply take the square root. And so that's exactly what I did on this slide. So I isolated the x, so like on the first example, I added the 36 to both sides, then I divided everything by 4, so again, following reverse PEMDAS, and then to get from x squared, I simply took the square root of both sides, is what I did. And the same thing applies here. Just remember that you'll also have to divide by the coefficient in front first. That was the only thing that happened here. This was a word problem. I actually ended up drawing the whole thing out, so I don't think you even needed sound. And then where I ended was this slide. Now this slide was very important, and I'm actually going to start today's lesson here. So let me maximize this for a little bit. This is for the next method on how to solve a quadratic equation. And this method is called completing the square. This is my least favorite method. In general, you use it with problems where you can't use the square root method for whatever reason, or you can't factor it, like it might be unfactorable. Remember, like not every method will work on every problem necessarily. And so, there are advantages to factoring if it's easily factorable. There are advantages to taking the square root method if it's easily square rootable, let's say. But sometimes neither of those methods work, and instead the best method, and again, I don't really like this method, I think it's long and complicated, is something called completing the square. So what I'd like you to start by doing is copy down all these steps. So pause the video and copy down these steps to how to solve a quadratic equation by using this particular method. This is the title's at the top, but how to solve quadratic equations by completing the square. That's what today's lesson is going to be about. So step number 1 is you want to basically isolate the x's. Okay, so let me go ahead and get my tools out here. So step 1 is isolate the x's. So any term that does not have an x, move it to the other side. So notice that this term obviously, notice that this term obviously has an x in it because it's an x squared, so you're going to leave it on the left side. This term has an x in it, a 6x, so you're going to leave it on the left side as well. This term does not have an x in it, so it belongs on the other side of the equal sign, which is correct. So this problem is already set up for us. Everything with an x is on the left side, everything without an x is on the right side. So that's how you set up a problem for completing the square. Okay, then in step 2 it says that they added 9 to both sides. Now how did they get that number? Because that is something you have to do. You have to add a number to both sides. But in order to find out what number that is, you have to do a few things. First, what you need to do is label the b. Label the b. So remember, quadratic equations are set up x squared plus bx plus c equals 0. And basically what we're doing here is we've moved the c to the other side, right? So now what you're at is you're at an x squared plus bx equals c, right? So first identify the b. So let me actually go back to step 1 to do this. Or you know what, let me do it on step 2 because it's easier to see. So the b is 6, right? So let me write that over here. B equals 6. And so you're going to do two things to it. First, you're going to do b divided by 2, and once you have whatever number that is, you're going to square it. So b divided by 2, then squared. That's the number, this number, that you're going to add to both sides. So for example, if our b is 6, that's 6 divided by 2, and then we're going to square it. 6 divided by 2, of course, is 3. 3 squared, 3 times 3 is 9. So that's how they get the 9. That's how you find the number that you're going to add to both sides. So again, if I were you, write this down. So add this number to both sides. Find the b, whatever the b is, divide it in half, and then square it. Whatever number you get, that's the number you add to both sides. So now look what they did. On the left side, you started with x squared plus 6, but what did you add to it? You added the 9, just like we said we'd do over here. And then on the right side, we had the negative 2. What is negative 2 plus positive 9? Well, it's basically the same as 7 minus 2. That's how they got the 7, okay? That's how you got to step 2. And that right there is basically the most important step in completing the square. Now, the whole point of doing that is that now, instead of just x squared plus 6, now you have x squared plus 6x plus 9. And what that is that's a perfect square. That means you can factor it into something plus something or something minus something times itself. So again, this method a little confusing perhaps, especially the first couple times you do it. When you factor x squared plus 6x plus 9, that's a perfect square. It actually comes out to, like it says here in step 3, x plus 3 squared. So step 3 is basically factor the expression on the left as it says. And again, it only works if you did step number 2 correctly. If you did step 2 correctly, then you're going to have a perfect square trinomial, either positives or negatives. So for example, this is positive, so it's x plus 3 squared. How do you know you did it right? Well, you can always FOIL that back out, right? Like you could do, okay, well, x plus 3 squared, that's a squared, not a c, is the same thing as x plus 3 times x plus 3. Do FOIL, and you'll find out that, yes, that is x squared plus 6x plus 9, so you know you did it right. Then what you're going to do in step 4, and it actually says it here, is you're going to take the square root of both sides. Now remember that a square root and something something squared cancel each other out, leaving you with the something something, which looks like an m. I guess I drew an m, whatever. That's the part that's going to pop out. So in the example here, this square root, and this square are going to cancel, leaving you with the x plus 3. So that's what you get in step number 5. Step number 5 is just like rewrite everything, right? So step number 5, you rewrite everything. So you have the x plus 3, that's what popped out. And on the right side, the square root of 7, it's important, as we mentioned in the last lesson when you couldn't hear me, but it's important to know that when you take a square root, it can be positive or negative. So x plus 3 equals plus or minus the square root of 7. Then, because you want x by itself, simply subtract the 3 from both sides. Again, you're doing the opposite. So instead of adding 3, you're subtracting 3. And so you end up with x equals plus or minus the square root of 7 minus 3. And that's your answer. So this is your answer right here. Now, remember that plus or minus, there's both a plus and a minus. There's a positive and a negative. So you can separate the answers, and that's what they did here. So here's the positive answer. X equals positive square root of 7 minus 3, and then here is the negative answer, x equals negative square root of 7 minus 3. Okay, so that's how you complete the square. So now let me go to the actual lesson for today. Oh, I should probably point out, make sure you pause the video and take notes, okay? So I'm going to flip over to the actual lesson for today right here. Here's the heading. You can pause it if you need to. And without bothering with an I can't say, let's just get into it. So again, the whole point of completing the square is to make it into a perfect square, so that then you can factor it. So I'll do the first example here. Then I'll let you try with the other one. So again, I'm just going to rewrite it. X squared minus 16x, and I'm going to make sure I set it equal to 0 because I don't actually see any other numbers here. And so what I'm going to do first is I'm going to identify the b. So I'll write that on the side. So b is negative 16. What am I going to do with it? I'm going to do b, cut it in half, and then I'm going to square it. So I'm going to get negative 16 divided by 2, and I'm going to square it. What is negative 16 divided by 2? Well, it's negative 8. Negative 8 squared is positive 64, because negative 8 times negative 8 is 64. This is the number that I need to add to both sides. So I'm going to get x squared minus 16x plus 64. So I've added it to the left side. Obviously, I have to add it to the right side. So 0 plus 64, that's going to be 64. Now, if I did this correctly, the left side is a perfect square, so it should be relatively easy to factor. So I'm going to go ahead and do that. On the left side, this is the same thing as x minus 8 squared. And that's of course because when you subtract, if you do FOIL, right? So x times x, that'll be x squared. Outside times outside, that'll give you negative 8x. Inside times inside, another negative 8x. There's your negative 16x. And then last times last, negative 8 times negative 8 is positive 64. Right? So that's how you factor if you did it right. And again, the other way to think about that, of course, is what two numbers multiply to 64, but add to negative 16x, and it's negative 8. If you're really still confused about this, a shortcut to this, when you get good, I mean, maybe don't jump to it yet. A shortcut to finding how to factor is that it's actually this step right here. Whatever number was inside the parentheses after you did b divided by 2, that's basically always going to be your factor. So there's your factor, x minus 8. Okay. Now on the right side, back to where we were, I'm going to rewrite the 64. Now the next step. Step number, what is it? Step 4, 3, I don't even remember. What you're going to do is you're going to take the square root of both sides. So now when I square root this side, I have to square root this side. The square root and the square will cancel, so the inside pops out. So I'm going to be left with x minus 8. On the right side, the square root of 64, remember now we're writing plus or minus 8, because positive 8 times positive 8 is 64, but also negative 8 times negative 8 is 64. Then you simply add 8 to both sides and you're done. So x equals plus or minus a square root, well, not a square root anymore, plus or minus 8 plus that 8 that you brought over there. Okay? And so that's basically your answer. But I do want to point out sometimes there are like differences depending on like what problem you're doing. They might ask you to find the actual solution. So let me write that out over here. So my answers are x equals negative 8 plus 8, but also x equals positive 8 plus 8. Because depending on what platform you're working, maybe they'll actually want you to find the exact answer. And that's not hard to do. What is negative 8 plus 8? Well, it cancels, so x equals 0. And over here, 8 plus 8 is 16. So those are your like actual two answers if you were to simplify it all the way. Okay, so now using all that work, try to solve that next one, x squared plus 16x, and I'll move on to the next slide otherwise. So pause the video and practice. Okay, now obviously it's not always as easy as that problem that we just did. Sometimes there's more to it. So I'll work this one out with you as well. This is actually like that very first example that we did at the end of the other lesson, so to speak. So this one you have another number on the other side. And listen, it's not going to change anything. I mean, obviously, I didn't change anything, right, between those last two examples I did. So you might actually be able to do this on your own. So try it on your own. Otherwise, I will put the work for this on the screen right now. So I have x squared plus 10x equals 75. Somewhere off to the side, I'm going to identify that my b is 10, and I'm gonna divide it in half and then square it. So I'm gonna get 10 divided by 2. I'm just gonna write it. It's 5. Okay, so if you don't know, 10 divided by 2, it's 5. 5 squared, of course, is 25. Remember, I told you this number in here, that's gonna be like my shortcut, right? That's gonna be the solution to my factoring, so to speak. But otherwise, this number, the 25, that's what I have to add to both sides. So I'm gonna get x squared plus 10x, and I'm gonna add 25. On the right side, 75 plus 25, that's going to be 100. Okay. On the left side, I now factor it, and again, shortcut, I already know what it's going to be. It's going to be this number back over here, so that's x plus 5 squared equals 100. And again, double check, because when you FOIL it out, what number times itself equals 25, but added to itself equals 10, and that of course is 5. Then you take the square root of both sides. So I'm going to square root that side, I'm going to square root that side. Square root and square cancel, leaving me with x plus 5 equals the square root of 100. What times itself equals 100, and that's plus or minus 10. And let me move this up here now. So now I'm going to subtract 5 from both sides. So I'm going to get x equals plus or minus 10 minus 5. And I can separate my solutions. So I'm going to have x equals positive 10 minus 5, and I'm also going to have x equals negative 10 minus 5. 10 minus 5 over here, x equals 5, and over here, negative 10 minus 5 gets more negative, so that's x equals negative 15. And there are my two answers. Nice and easy. So again, long, complicated, I don't really like it, but sometimes it's the only method that is relatively easy enough to do. So, you got to do it. All right, next slide. Here are two more examples that are basically the same as the one that we just did. Please try them on your own. Pause the video, work them out, etc., etc. Ask me questions if you have questions. Okay, this slide is another example of shortcuts that you can take. And it's basically saying that if the A is a perfect square, and we haven't talked about the A yet, right? Like we've been focusing on the B. This slide is saying that if the A is a perfect square, then it's very easy to find the number that you add to both sides, because all you have to do is do b squared divided by 4a, and that will tell you what number to add to both sides. So let me write this out, because this is a shortcut, but it only makes sense if you're good at completing a square, which, I mean, let's be honest, you've only been doing it for like 20 minutes so far, so you might not be here yet. But let me write it out, and maybe it'll make sense to you. Otherwise, if I were you, I'd probably come back to this later, like after I do at least the first 5 problems of homework from 22.2 at least, something like that. Okay. All right. So here we go. I'm going to have 25x squared plus 10x equals 12. So before I even start completing the square, what pops out to me is that the A, this number out here, is a perfect square, because of course 25 is a perfect square because 5 times 5 equals 25. So if A is a perfect square, and this only works if A is a perfect square, then I use that little formula they have up here, b squared divided by 4a. That's a shortcut to finding out what I'm going to need to add. So b squared divided by 4a. b, as you can see, is 10. It's going to be 10 squared divided by 4 times a, which is 25. 10 squared is 10 times 10, which for some reason my marker's not working. 10 times 10 is 100, divided by 4 times 5, which is 100. 100 divided by 100 is 1. This is the number we're going to add to both sides. Okay, so it's going to be 25x squared plus 10x plus 1 equals 12 plus 1, which is 13. Now, again, this was just a shortcut. This hypothetically takes less time than doing all the other stuff. Sometimes this is like easier than anything else, and that's what it's saying, right? So the left side is now going to be 5x plus 1 squared. And how did I know that so fast? Well, the first and last terms is what you focus on. So what times what is 25x squared? Well, that's 5x, because 5x times 5x is 25x squared. And how do you get to 1? Well, 1 times 1 is 1. So again, this is how I got that. This is how I got that. And then all of this equals 13. Take the square root of both sides, and you're going to get 5x plus 1, because the inside's going to pop out, equals plus or minus the square root of 13. Whatever it is, we don't know because it's irrational. Then simply subtract 1 from both sides, and you'll get 5x equals plus or minus square root of 13 minus 1. And then divide both sides by 5, and you'll get x equals plus or minus square root of 13 minus 1 divided by 5. Notice that I'm leaving it in this irrational form specifically because the square root of 13 is an irrational number. So for example, when I subtracted the 1, I didn't bother finding out what is the square root of 13 and then subtracting 1. I don't know what it is. It's irrational. So I'm going to leave it as plus or minus square root of 13 minus 1. Same thing when we divide by the 5. All we're doing is we're getting the x by itself, but otherwise we're not messing with the form. We're just going to leave the answer exactly like that. Okay, but again, the shortcut was this stuff right here. That's how you know what to add to both sides if the first number is a perfect square. Now some of you are like, oh, I like this. I like it when the first number is a perfect square. Great, try it on these two problems. Pause the video, work it out. But also, even if the first number is not a perfect square, you can make it a perfect square. And so again, for those of you that are about to be really good at completing the square, this ends up being a technique that can help you solve completing the square problems in a very short amount of time. So I'll do this one for you. So this one says, oops, so this one, oh, where'd it go? There we go. So this one says 5x squared plus 2x equals 6. So in my mind, I'm like, okay, well, I really liked that technique because it's really easy to do the b squared divided by 4a, but that only works if a is a perfect square. 5 is not a perfect square because nothing times itself equals 5. That would be an irrational number, right? But I can make it a perfect square. So the next perfect square that I can think of is, well, maybe 25. Maybe I just multiply everything by 5, and you can do that, right? Like as long as you multiply every single term by the same thing, it's equivalent. It doesn't change. So what I'm going to do is I'm going to multiply everything by 5 real quick. So I can do that in my head, but just because this is a PowerPoint, I'm writing it out to show you. But so if I multiply everything by 5, then I'm going to get 25x squared plus 10x equals 30. Now I can use that same technique that I did on the previous slide. Because a is a perfect square, now I can simply do b squared divided by 4a. So b squared, that's going to be, that over here, that's going to be 10 squared divided by 4 times 25. Notice it actually is the exact same thing, right? So that's going to be 100 divided by 100. So 100 divided by 100 equals 1. So that's the number I'm going to add to both sides. So I'm going to have 25x squared plus 10x plus 1 equals 30 plus 1. So that's 31. The left side factors perfectly. So that's 5x plus 1 squared equals 31. Square root both sides, and I get 5x plus 1 equals plus or minus the square root of 31. It's irrational, right? So that means, again, just like that last example, I'm kind of going to leave it there. I'm going to subtract the 1, and I'm going to get 5x equals plus or minus square root of 31 minus 1, and then I'm going to divide everything by 5. So I'm going to get x equals plus or minus square root of 31 minus 1 all over 5. And that's it. That's all I have to do. Notice that probably from when I started this problem to when I ended, it was what, like maybe 1 minute to solve it-ish? Look at the YouTube video and find out exactly how long, I guess. But it's actually pretty easy once you get the hang of it. So using that technique, try these two problems out. Again, what you're going to need to do is you're going to need to make it a perfect square. Make the a perfect square. So for example, 1/2, you have options. You can make it even more of a fraction and go to 1/4. That means you'd multiply everything by 1/2 and you'd end up with this complicated fraction. If I were you, my suggestion on that is to actually multiply everything by 2, because the 2 and the 1/2 will cancel, leaving you with x squared, or 1x squared, which is a perfect square, right? 1 times 1 is 1. On the second one, obviously, just multiply everything by 2 and you'll have 4x squared, which is a perfect square. But anyways, try those out. Let me know if you need help. This formula is something you'll need for the next two problems. So go ahead and write down the formula that you see on the third line there. That's gravity, basically. So whenever anything falls on Earth, that's how you find out how fast it's falling. So it's negative 16t squared plus vt plus s. And like it says there, t is time in seconds, v is the initial velocity, and s is the initial height. So make sure you have that written down. Okay. And you can use that to solve this problem. Okay. So this says that a person throws a shot put 6 feet from 6 feet above the ground. So let me just point out that that would be your initial height. So if I go back, where would that go? That would be the s, the initial height. Great. And at an initial velocity of 20 feet per second. So let me just go back. That would be your v, your initial velocity. So that's where you'd plug those in for the s and for the v. Okay. What is the maximum height? And let me just go back again. The maximum height. Let's see, the height. Well, that's what you're solving for, right? That's the h. That's what you're going to solve for. And when will it hit the ground? So I'm actually not going to help you on this problem. Well, I kind of already did. I told you what to start plugging in. So start plugging those in. And what you're going to realize is that after you plug in the information they give you, you have a simple quadratic function. Once you have it written out, use completing the square and see if you can get the right answer. Okay? Same thing for this problem. So these are basically the last two problems that I wanted to leave you with, are like challenge problems. I believe they come from the latter part of your homework, somewhere in the teens. But again, they're giving you some key information. Again, initial height and initial velocity are given to you. Once you plug those into that equation that I had shown 2 slides ago, you're going to be able to see that it's a basic quadratic equation and that you can use completing the square to solve it. And this is kind of like answering the question, well, why would I ever do completing the square if it's this annoying? Sometimes it is actually a good method. I don't really like it myself, but it works. Okay, so at this point you should be able to do the exit ticket. One thing I should point out is that this was actually a combo lesson. It was both 22.2 and 22.3, so you should be able to do both the second and third exit tickets from this lesson. All right, and then if you needed some extra practice, because when I do this lesson in person, usually kids want a little bit of extra practice before they try the exit ticket or before they do their homework for this, which remember is 22.2 and 22.3. Here's also a few additional problems that you might want to try out. Okay, and again, that's only if you need the extra help. Otherwise, I will see you all during a live Zoom meeting. I'm going to go ahead and end the lesson here. Peace out.